Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve these interesting integrals. So here we have three integrals. So if we look at carefully, here we have this integral is square root. So here we know 2, here 4, here we have 3, here 6, here 4, here 8. So I am going to generalize this integral. So we can write integral from 0 to 1 natural log of x over kth root of 1 minus x raised to the 2 times k dx. Now when k is equal to 2, we know here we have fourth power this integral. When k is equal to 3, we have this integral. When k is equal to 4, we have this integral. So we can generalize this integral. Okay, how to begin? Well, first let's try with the u substitution. Here we have 1 minus x raised to the 2 times k power. So I am going to take 1 minus x raised to the 2 times k is equal to t. Then we can isolate the x. X is equal to 1 minus t raised to the here 2 k power, so 1 over 2 times k. Now we can differentiate. So here dx is equal to here minus t, so we have minus according to power rule 1 over 2 times k, 1 minus t raised to the 1 over 2 times k minus 1. Now we can plug in. So we have let's take this integral is equal to I. So we know now I is equal to here limit. We know when x approaches to 0, lower limit. When x approaches to 0, t approaches to 1. Upper limit when x approaches to 1, t approaches to 0. Then natural log of x. X we know 1 minus t raised to the 1 over 2 times k power over here 1 minus x to the 2k power, we know t. So we have kth root of t, and here dx we know minus 1 over 2 times k 1 minus t raised to the 1 over 2 times k minus 1 dt. Here I forgot to write dt. Okay, then we can simplify. Here we can change upper limit and lower limit. When we change the limit, this minus sign get cancelled. So here integral from 0 to 1. Now we know here we have 1 over 2 times k, and here in the numerator natural log 1 minus t to the 1 over 2 times k. So according to property of natural log, this 1 over 2 times k we can write in front of the natural log. So 1 over 4 times k square. Then here we have kth root of t. So we know this is equal to t to the 1 over k power. If we take t over 1 over k in the numerator, we know t to the minus 1 over k power. Then 1 minus t raised to the here 1 over 2 times k minus 1 power times natural log of 1 minus t dt. Okay, then we know definite integral independent of the variable. So instead of t, I am going to write x. So we can write I is equal to 1 over 4 times k square integral from 0 to 1 x raised to the minus 1 over k 1 minus x raised to the 1 over 2 times k minus 1 times natural log of 1 minus x dx. Okay, now how to solve this integral? Okay, here if you look at carefully, you can see the relation with the beta function. So let's call the beta function. So we know integral from 0 to 1 x to the m minus 1 times 1 minus x to the n minus 1 dx is equal to beta of mn, and we know the relation between beta function and gamma function. Gamma of m, gamma of n over gamma of m plus n. Okay, then I'm going to differentiate both sides with respect to n. So with respect to n, so we have integral from 0 to 1 x to the m minus 1 1 minus x to the n minus 1 natural log of 1 minus x dx, and right hand side we have gamma function. Gamma of m we know constant because we are differentiate with respect to n. So now we can apply quotient rule. Here we have gamma square of m plus n, and here gamma of m plus n times derivative of gamma of n, we know gamma dash of n, then minus gamma of n, then a derivative of the denominator gamma dash of m plus n. Okay, then we know this integral here also we have this integral. This type of integrals, these are not same but same type of integrals. Okay, let's simplify. So here we have a gamma of m, then here if we divide by gamma square of m plus n, we know this gamma of m plus n get cancelled, so we have gamma dash of n over gamma of m plus n minus, then here we have gamma of n, gamma dash of m plus n over gamma square of m plus n. Okay, then still we can simplify by using digamma function. We know gamma dash of n is equal to gamma of n times digamma of n. We proved this identity in a previous video, digamma function video. If you like to watch, I will add the link in the description so you can watch it. Okay, then here we can write this is equal to gamma of m times gamma dash of n over gamma of m plus n, here m plus n minus gamma of n times, instead of gamma dash of m plus n, we can write gamma of m plus n times digamma of m plus n over gamma square of m plus n. So we know now gamma of m plus n, this square, these two get cancelled, so we have gamma of m times here gamma dash of n over gamma of m plus n minus, here we have gamma of n times digamma of m plus n over gamma of m plus n, and we know this is equal to integral from 0 to 1 x to the m minus 1 times 1 minus x to the n minus 1 natural log of 1 minus x dx. Okay, then I'm going to apply instead of n 1 over 2 times k, and instead of m 1 minus 1 over k. So we know here integral from 0 to 1. Now x raised to the m minus 1, m we know 1 minus 1 over k, so 1 minus 1 over k minus 1 get cancelled, we have minus 1 over k times 1 minus x to the n, we know 1 over 2 times k minus 1 natural log of 1 minus x dx. Now this side, right hand side, we have gamma of m, we know 1 minus 1 over k. Then here gamma dash of n, so gamma dash of 1 over 2 times k. In the denominator, gamma of 1 over 2 times k plus 1 minus 1 over k, so gamma of 1 minus 1 over 2 times k. Then here minus gamma of n, we know 1 over 2 times k, digamma of 1 minus 1 over 2 times k over gamma of 1 minus 1 over 2 times k. Okay, now here we have our integral. We know this is I 4 times k square, this 4 times k square times I is equal to this integral. So here we have same integral. So we know now we have 4 times k square times I is equal to now here we have gamma of 1 minus 1 over k over here we have gamma of 1 minus 1 over 2 times k times here we have gamma dash of 1 over 2 times k. So we know gamma dash of n, gamma of n times digamma of n. So we can write here gamma of 1 over 2 times k times digamma of 1 over 2 times k, then minus gamma of 1 over 2 times k times digamma of 1 minus 1 over 2 times k. Okay, then here we have gamma of 1 over 2 times k, here gamma of 1 over 2 times k we know is a common factor, so we can take outside of the parentheses. And also here we have gamma of 1 minus 1 over k, here same type of function, gamma of 1 minus 1 over 2 times k. So what do you think, how to simplify this function? Well, we have gamma of x times gamma of 1 minus x is equal to pi over sine of pi x, Euler's reflection formula. So let's call the Euler's reflection formula. So we know now gamma of x times gamma of 1 minus x is equal to pi over sine of pi x. Now instead of x, I'm going to plug in 1 over k. So gamma of 1 over k, gamma of 1 minus 1 over k is equal to pi over sine of pi over k, sine of pi over k. Then we can isolate the gamma of 1 minus 1 over k. We know this is equal to pi over gamma of 1 over k times sine of pi over k. Well, then here we have gamma of 1 minus 1 over 2 times k. So similarly we can write gamma of 1 minus 1 over 2 times k is equal to pi over gamma of 1 over 2 times k times sine of pi over 2 times k. Okay, then we can simplify. Here we have 4 times k square I. So 4 times k square I is equal to now gamma of 1 minus 1 over k over gamma of 1 minus 1 over 2k. So if we divide this, we have gamma of 1 over 2 times k sine of pi over 2 times k, and here we know gamma of 1 over 2 times k is a common factor. So gamma of 1 over 2 times k over, now here we have gamma of 1 over k times sine of pi over k, sine of pi over k. Then parenthesis, here we have diagram of 1 over 2k, diagram of 1 minus 1 over 2k. So diagram of 1 over 2 times k minus diagram of 1 minus 1 over 2 times k. Okay, then let us simplify. I'm going to rearrange this here I, we can isolate the I, 1 over 4 times k square. Then here gamma of 1 over 2 times k, gamma of 1 over 2 times k over gamma of 1 over k, gamma of 1 over k. Then here we have sine of pi over 2 times k over sine of pi over k. So we know the double angle formula. So here 2 times sine of pi over 2 times k cosine of pi over 2 times k. Then here we have the relation between diagram of function. We know we proved diagram of x minus diagram of 1 minus x is equal to minus pi times cotangent of pi x. This is the formula. Diagram of x minus diagram of 1 minus x is equal to minus pi times cotangent of pi x. If you're interested to watch the derivation of this formula, you can watch my diagram of function video series. Okay, then we know here we have minus pi times cotangent of pi x, so we can plug in. So instead of this part, we know we have minus pi times cotangent of pi x. Pi, now instead of x we have 1 over 2 times k, so pi over 2 times k. Okay, then we know I is equal to 1 over 4 times k square. Now here we know this is equal to beta function, so we have beta of 1 over 2 times k comma 1 over 2 times k. Then here sine of pi over 2k, sine of pi over 2k get cancelled. So we have here we have 2, so 2, and cotangent, we know cotangent cosine over sine, so cosine function also get cancelled. So we have sine of pi over 2 times k. Here we have minus pi. So now we can rearrange this like minus pi over 4 times 2, we know 8 times k square times beta of 1 over 2 times k comma 1 over 2 times k over sine of pi over 2 times k. Okay, this is the generalized answer.